Hello everyone. Today we are starting with our first data structures and algorithms coding series. And we will start with our first problem, to sum, when input array is sorted. So let's understand the problem first. We have an indexed array of integer numbers that is already sorted in non-decreasing order. And we have to find two numbers such that they add up to a specific target number. Suppose, for example, we have some numbers like 2, 7, 11, 15, and this is our array. And we have a target 9. And then we have to identify the indices of any two numbers which sum up to our target. And the tests are guaranteed that there is at least exactly one solution. And we should not use the same element twice. So these are the additional notes which is given in the problem. So let's understand the problem. Let's say we have our numbers 2, 7, 11, and 15, and this is our array. And our target is 9. So let's understand this. So we know that the brute force algorithm is like check each number with other number, like check 2 with 7. Like if it sum up, if it's 9, then we can return this 1 and 2. And if it's not summing up, then we will check 2 with other number like 11, and 2 plus 11 is not 9, and then we will check 2 with other number like 2 plus 15. And if it's not doesn't match, then we will increment this, and then we will again come add up 7 plus 11 and 7 plus 15. Again we will increment and we'll do 11 plus 15. Because this solution is a two loop solution, the brute force algorithm will be O of n square. Can we do better than this? Yes. So we can do better than this by using something called as two pointer approach. Yes. So what is a two pointer approach? So let's say we have these numbers again, 2, 7, 11, 15. The additional notes from our description of the problem is these numbers are sorted. So we can use this additional information to our advantage to solve this problem in O of n time. So how to do that? So let's have two pointers, I comma j. Let I point to the starting element I, and let j point to the end element j. So now we have I pointing to the first element, j pointing to the last element, and our target is basically 9. Let's sum up I and j. Our 2 plus 15, which is 17. Our 17 is greater than or equal to target. So if our sum is equal to the target, then we can return the indices of this I and j. But because this is greater than the target, we have to reduce this sum. Since it's sorted already, we know that if we are reducing the reducing the last index to let's say j, if we are reducing it to j minus 1, we always know that the sum will be lesser than the previous sum. Like 2 plus 11 is always less than 2 plus 15. That's because the numbers are already sorted. So if the sum is actually greater, then what we will do, we will decrement the j. So now our j is pointed to 11, and then I remains same. So now we will do 2 plus 11, and our sum is 13, which is again greater than 9. If it's greater than 9, we will again decrement j. So now our sum is 2 plus 7, which is equal to 9, and 9 equal to 9. Then we will return indices of I and j. So I is basically the first index and j is basically the second index. So then we will return 1 comma 2 here. So let's take another example where we will see the increment of I as well. So let's say we have again 2, 7, 11, 15. And let's say this time our target is 18. So again the same two-point approach. I is pointing to the first element, j is pointing to the last element. Let's do I plus j, 2 plus 15, 17, which is actually less than our target, 18. So if the sum is actually less than the target, we know that we need to increment this, the left side pointer. We will increment I. So now I is pointing to 7, j is pointing to 15. So 7 plus 15 is basically 22. 22 is greater than 18. So whenever the sum is greater than 18, then we will decrement j. Now we got I plus j, 7 plus 11, which is 18. And our sum is equal to 18. And we will return I and j indices. I is basically the 2 now, and j is basically the 3. So this is basically the algorithm of two-point approach. That's how we solve this problem. So let's code it up now. So we know that we have I and j pointers. I is pointing to the initial element, and j is pointing to the last element. So we will iterate until I is less than j, and then we will calculate the sum of I plus sum of j. If sum equal to target, we know that we need to return the I and j indices. But here arrays starts from 0 index, but we need to return one indexed array. So that's why we'll just add 1 here. So let's say if sum is less than target, we know that we need to increase sum. Whenever we need to increase sum, we need to increment I. And if sum is greater than target, so there are only three possibilities: sum is equal to target, or sum is less than target, or sum is greater than target. So whenever sum is greater than target, then we will decrement j. And we know that we'll have at least solution, but just for safer side, let's return our dummy variables. Let's try to run the test cases. Yes, it's passed, and let's see. Yes, the result is accepted.